All right, welcome everybody. Today we're going to talk about lesson number 68. This is section 9.2, and today's lesson is all about arithmetic sequences. So arithmetic sequences, when you hear those, you're going to think of linear, which means they have to take the form y equals mx plus b. This is going to be a little bit of a shorter lesson, which means that the next lesson is going to be a little bit of a longer lesson. So just make sure you plan accordingly. There's homework number 68 if you have to write those problems down. And then as we proceed through this lesson and the next couple lessons, you might want to think about making yourself kind of a running formula sheet, taking all the formulas that we've learned so far and adding in all the new ones, just so you have a nice, easy reference guide as we head towards the next assessment. So in order for a sequence to be arithmetic, it can only be that way if the differences between consecutive terms are in fact the same. So if you have the sequence A1, A2, A3, all the way up to AN, it would only be classified as arithmetic if there was something called a common difference, and we're going to use D to represent the common difference. And in order for the common difference to exist, you would have to be able to subtract any pair of consecutive terms and always wind up with the same difference D. So if you did the second term minus the first term, it would have to be equal to the third term minus the second term, which would have to be equal to the fourth term minus the third term, and so on and so forth. Make sure that when you are calculating the common difference, you are doing the back term minus the front term. So you would do the second term minus the first term. You would never do the first term minus the second term. You always have to do the later term minus the earlier term. Here are some examples of arithmetic sequences. These are probably the ones that you are the most familiar with, and also the ones that are the easiest to identify. So 3, 8, 13, 18, 23, in order for you to be 100% sure that this is in fact an arithmetic sequence, you would have to take any two consecutive terms, subtract them, and verify that you get the same common difference every time, remembering that you have to do the later term minus the previous term. So let's just pick any pair. Let's say 18 minus 13. If you do 18 minus 13, you do in fact get a common difference of 5, which is why number 1 is an example of an arithmetic sequence. If you take a look at number 2, you can see that the values are going down. That means that the common difference, of course, has to be negative. And again, you would find that common difference by choosing any pair of consecutive terms, subtracting them, let's say 50 minus 75, and that's how you would get a common difference of negative 25. Now, a word of caution, obviously, since we are in section 9.2, which is titled Arithmetic Sequences, you kind of assume that the majority of problems in this section are in fact going to be arithmetic. That is, of course, the case. But be careful, because as the chapter progresses and we learn about other kind of sequences, you're going to want to verify first that it's arithmetic and not just assume. In example 3, I start actually by giving you an equation, 4n plus 3. You would start by plugging in the first, second, and third term. Then you would go ahead and look at the resulting values, choose a pair of consecutive terms, subtract them, back minus front, and that's how you would verify that this is in fact an arithmetic sequence with a common difference of 4. So the first thing you have to be able to do here in these first 3 is be able to identify whether or not something is arithmetic. And if it is, you would have to be able to find the common difference D. In terms of equations, there are actually a couple. The first thing to remember is that any sequence that is arithmetic must also be linear, and anything that's linear has to, of course, follow what we always know for things that are linear, which is y equals mx plus b. If you're looking for an arithmetic formula that is almost exactly equivalent to y equals mx plus b, you're going to use this first version, which is a sub n equals dn plus c. The way that that corresponds to y equals mx plus b is that d is the common difference, which would be equivalent to the slope. The c would be the y-intercept, or the zeroth term. In order to find the zeroth term, you would have to do whatever the first term is minus d. That would basically go one term previous, which would of course be the zeroth term, which is the y-intercept, so that's c. And then n would be the term number. So if you're looking for an exact correlation between y equals mx plus b, this is the form of the arithmetic sequence that you would use. But there's also a second one. So again, as a reminder, here's the linear form of the arithmetic sequence. Then there's something called the alternative form of the arithmetic sequence, which basically allows you to relate any two terms in an arithmetic sequence. sequence. So here's our second formula. A sub n equals a sub 1 plus n minus 1 times d. This n minus 1 represents the position number. By using this alternate form of the arithmetic sequence, you're basically relating any two terms based on the number of common differences between them. So if you look at the first one here, a sub 1 is of course equal to itself because there are no common differences between the two terms. Whereas in the second one, if you wanted to find a relationship between the first term and the second term, there are exactly one common differences between those two. From the first term to the third term, there are exactly two common differences between them. Notice that you do not have to always have a sub 1. You can, in fact, relate any values. So let's say you wanted to relate the 10th value and the 6th value. There are exactly 4 common differences between 6 and 10, so you'd be able to use this alternate form as well. Both of these versions have their place. They both have pros and cons. So there are some problems I'm going to do with the first form. There are some problems I'm going to do with the second form. And then there are some problems that I'm going to do both ways just to show you that they would be equivalent. Another warning about these arithmetic sequences is I know it's tempting to kind of just guess and check the answer, and not that that doesn't work, because it does, but again, as the chapter progresses, you're going to have more and more types of sequences, you're going to have more and more types of sums, you're going to have more and more formulas. So the more you actually use the appropriate formulas, I think it just kind of makes things a little bit clearer. So here's an example. Find a formula for the nth term of the arithmetic sequence if d is 5 and the first term is -1. So because of the fact that we have the first term, we're going to go ahead and use the form a sub n equals dn plus c. The good news about this is we already know what d is, so no need to solve for that. In order to use this form of the equation, we would have to know what c is. Remember that c is essentially the 0th term, which is, of course, the y-intercept. In order to find that, you're always going to do the first term, which we know, minus the common difference, which we also know. So c is going to be equal to -1 minus 5, which is equal to -6, which means that the formula for this in particular arithmetic sequence is a sub n equals 5n minus 6. So this formula represents this arithmetic sequence. And again, once I have this formula, I could now find any term in the sequence that I wanted by plugging in the appropriate n value. Find a formula for the nth term of the following arithmetic sequence, 5, 9, 13, and 17. And again, I'm going to do this both ways just to show you that they're kind of equally difficult or equally easy, and certainly the answers are the same and equivalent. So for a formula to be used, the first thing I have to know is what is the common difference d. So again, the common difference can be found by taking any pair of consecutive terms, if in fact it is arithmetic, which again, I'm telling you that it is, and subtracting the back term minus the front term. So 13 minus 9 gives me a common difference of 4. Let's go ahead and start by doing this problem by doing a sub n equals dn plus c. I already know what d is. To find c, I would again do the first term minus d, which would be 5 minus 4, which is 1. And that would give me a formula of a sub n equals 4n plus 1. Again, perfectly fine way to do this problem, and you certainly get the correct answer. Let me go ahead and show you another way. So if we're going to use the alternate form of the equation, then we're going to say a sub n equals a1 plus n minus 1 times d. Again, this is also quite simple because we know the first term, which is 5. We're going to leave n minus 1 as n minus 1 and then plug in the common difference 4. We're going to go ahead and distribute. So 5 plus 4n minus 4. And you can see that if you combine like terms, you wind up getting that a sub n equals 4n plus 1. So obviously the two answers that you get are equivalent. I will not tell you in particular that you have to use one way versus another, depending on the information that is given in the problem and depend on what it's asking you for. You'll see that using the left side versus the right side might have pros and cons. But again, as long as you're able to do it somehow, that's really all that matters. Just another reminder here that if you are going to be using that alternate form, you can in fact modify it to reflect the difference between any two terms. So make sure you know that's not a sigma, I'm just underlining it. So from the 20th term and the first term, there are exactly 20 common differences between them. Between the 5th term and the 16th term, there are exactly 11 common differences between them. So the beauty of this second formula is it can be rewritten to find the difference between any two terms. So that's handy, and that's what we're going to use for our next example. So here in number 6, find a formula for the nth term if you know the 8th term and you know the 12th term. So in a case like this, we don't have the first term and we don't have the common difference. So there's actually a lot of information that we need to find. And the first thing you're pretty much always going to find is the common difference. So to find the common difference here, I am going to set up a relationship between the 8th term and the 12th term. So using that alternate form, I'm going to say that the 12th term is equal to the 8th term plus 4 common differences, because that's how many times you'd have to add from 8 to 12. If I know the 12th term is 41 and I know the 8th term is 25, I'm going to go ahead and plug those in. I'm then going to subtract 25, divide by 4, and that's going to tell me that the common difference is 4. If I then keep in mind that I'm going to use AN equals DN plus C, so keep in mind here I'm actually using both forms of the equation in the same problem, perfectly fine. In order to make this work, I'm going to have to go ahead and find C, which again is the 0th term. I don't know the first term, so the easiest way for me to find this is now to set up a second equation. Using either of these pieces of information, I usually tend to pick the one that is the smaller value, but certainly it doesn't matter. So I'm now going to say that A sub E is equal to A sub 0 plus 8D. That means that the 8th term is still 25. Now that I know that the common difference is 4, I'm going to do 8 times 4, which gives me 32. If I then subtract 32, I am able to find that the 0th term is equal to -7. Remember, that's the y-intercept, or essentially C. And now that I have exactly what I want, I can make my final answer, which says that A sub n is equal to 4n minus 7. As always, it's a great idea to check your work. The way that you could verify 100% that this was the right answer is if you plug in 8, do you get 25? And if you plug in 12, do you get 41? And if you do, then bam, you know that you've done it. If you want to verify whether or not you understand what's going on, you might want to pause the video and try number 7 here. It's almost the same type of problem, except now you're being asked to actually find the first 5 terms. So I'm going to find the equation first, just like we did in the previous example, and then calculate the first 5 terms. And again, feel free to pause the video, try it on your own, see if you're able to do it. So I'm going to go ahead and say that A sub 10 is equal to A sub 4 plus 6Ds. That would mean that 46 is equal to 16 plus 6D. Subtract 16, divide by 6, and you get a common difference of 5. If you're wondering, does it always have to divide evenly? No, I've kind of designed them that way so that it's a little bit cleaner, but it certainly doesn't have to. Now I want to find the 0th term, or C, so I'm going to set up another equation. And again, you could either use A sub 10 or A sub 4. I always tend to use the smaller value, but it would not matter. So A sub 4 is equal to the 0th term plus exactly 4Ds. There are 4 terms between the 0th and the 4th. So the 4th term is still 16. Looking for the 0th term. Because the common difference was 5, oops, sorry, that's plus, this is going to be equal to 20. If I go ahead and subtract 4, I'm going to get that A sub 0 is equal to -4. That is going to give me my equation, A sub n equals 5n minus 4. That is the equation for the sequence, but because they wanted the first 5 terms, don't forget to actually finish it by plugging in 1, 2, 3, 4, and 5. So if you go ahead and plug in 1, you get 1, 6, 11, 16, and 21. Again, there are lots of different ways you could get these answers, but my advice is to make sure you are using at least one of the formulas. I really think that the more you try to just guess and check, the harder it's going to be once you get more and more formulas. And believe me when I say there are a lot more coming. Our last example here is number 8. So here I give you the first term and the second term, and I ask you to find the 8th term. So again, I'm going to show you how to do it both ways, and then keep in mind that you could certainly do either. So because you know the first term and the second term, you're actually able to find the common difference by simply subtracting 1 minus 4, which is equal to negative 3. So once you know that, again, there are 2 different routes that you could take. So here's one route. If you want to find the 8th term, you could realize that that is equal to the first term plus exactly 7 differences. Because you know that the first term is 4, and because you know that common difference is negative 3, you're essentially doing 4 minus 21, which would tell you that the 8th term is negative 17. That is the right answer, and that's one way to go. Your other option here would be to use A sub n equals dn plus c. In order for this to work, you would have to find c. Because you know the first term, a1, you could subtract the common difference. So 4 minus negative 3. Of course, if you minus a minus, it becomes a plus, which is how you know that c is 7, which is how you get the final equation of a sub n is equal to negative 3n plus 7. That is the general equation for this sequence. And in particular, if you wanted to find the 8th term, that would give you negative 3 times 8 plus 7. And again, no matter which way you do this, you're going to get negative 17.